Hi Year 10. This is the third time I've made this video because the video software did not work properly in the first two attempts. So third time lucky, let's see how we go. All right, so what have I got here? We're looking at surface area of a prism. A prism is a 3D solid with straight edges and a uniform cross-section. So you can see all these prisms here have straight edges and they have a uniform cross-section. Okay, that means they have we can make each prism using uniform slices or the same shaped slices. So if I stack a whole lot of squares together, I make that cube. If I stack a whole lot of rectangles together, which are the same size as this front face, so then I'll make this prism. If I stack a whole lot of triangles together, I can make this triangular prism. And if I stack a whole lot of trapeziums together, I can make this trapezoidal prism. Okay, so uniform simply means same. Cross-section simply means slice. So I can make each one of these solids by stacking the same shaped slice. Okay, so we've got the cube here. We've got the rectangular prism here. Got the triangular prism here. And this is called the trapezoidal prism. Trapezoidal prism. Okay. Now each prism is named according to its uniform cross-section. So the uniform cross-section here is a square. We call it a cube. Here the uniform cross-section is a rectangle. We call it a rectangular prism. Here the uniform cross-section is a triangle. So we call this prism a triangular prism. And here the uniform cross-section is a trapezium. So we call it a trapezoidal prism. Now you need to know area formulas for this topic. Area of a square is x squared. That's given a square with all sides equal, obviously, and one side equal to x, because base, think about it, base times height is x times x, which is x squared. For a rectangle, we have base here, height here. The formula for the area of a rectangle is base times height. Now for a triangle, let's just rub this out for a minute. For a triangle, that's the height, and this line here is the base. Okay, so the formula for the area of a triangle is a half the base times the height. And for a trapezium, I'll just do it up here, some random trapezium. Here is the height. Now it's got two parallel sides for trapezium, side A and side B. The formula for the trapezium is h onto A plus B, where A and B are the two parallel sides. Okay, so let's move on to the first example. The surface area of a solid is the total area of all the faces of the solid. Okay, so our first solid here is a cube. We've got to calculate the surface area of this cube. So I'm just going to calculate the area of the front first. The front face is 4 times 4, which is equal to 16 square centimetres. And that means the surface area is, well, there's 6 identical faces on the cube, so 6 lots of 16 will give me 96 square centimetres. That's the first one. Now the second one, it says calculate the surface area of an open rectangular prism. Open means that the top is missing. So let's start off with the bottom. The bottom is just 25 times 8, which is 200 square centimetres. Now the sides the left and the right side are identical. So let's do the left side. The right side. The right side is 8 times 12. So 8 by 12, but the left side is the same. So we double that. We get the two sides together. So what's that? 192. You put them to your calculator. Now, we haven't done the front and back yet, so let's do the front and back together. So the front, the base is 25. The height of the front is 12. Okay, so we've got 25 by 12, and then we're going to double that because the back is the same. Okay, so 25 by 12 by 2, 600. Okay, so the total surface area, now we're just going to add these three numbers together, should get 992. Okay. All right, what about the next one? Well, the next one we've got a triangle, a triangular prism. So find the surface area. Let's start off with the bottom. Bottom is 8 by 10, which is 80 centimeters squared. Then let's look at the sides. Now in this triangle, the sides are identical, aren't they? Because we have a isosceles triangle at the front. That means we have an isosceles triangle at the back. So that side there is 5, and obviously 10 on both sides. That's 10 there, and this is 10 here as well. So the sides are the same, so we're going to have 10 by 5 and then double that to get the two sides together. That's 100. Now the front and the back are the same. You can see the front is a triangle. There's the base. There's the height. So it's a half times 8 times 3 and double it because the back is the same. It gives you 24 centimeters squared. So if you add that all up together, you should get 204 square centimeters. Okay, let's look at these two. Now, first one, to calculate the surface area, let's start off with an easy one. We'll go with the bottom. Whoops. The bottom is, now for some reason my pen is malfunctioning. Okay. Okay, that's not looking good. Okay, that's better. So let's just rub that out. There we go. All right. So rub that. All right. Now, so for my bottom, I've got 18 times 5. That's 90 meters squared. And let's do the front and back together. So the front and back are triangles. So I've got a half times 5 times 12 for the front triangle. The back triangle is the same, so we're going to double that. It gives you 60 square meters. Now the next easy thing to work out is the right side. So we'll do the right side first. The right side is going to be, well, let's have a look. The right side, the base of the right side is this length here. That's 18. So we're going to get 18 by 12. If you work out 18 by 12, 18 by 12 is 216. 216 square meters. Now the left side is a little bit different here. The left side, we are going to need to use Pythagoras' theorem because if you look at the left, we know what the base is, 18. but we don't know what the height is. Okay, so that means we're going to have to use Pythagoras' theorem because we have a right angle triangle here. There we go. There's the base of the right angle triangle. There's the height. Whoops. There's the right angle, and here's my hypotenuse. So I need to work out this side x. Now remember, Pythagoras' theorem is a squared plus b squared equals c squared. Remember, a and b are these two sides, and the longest side is always c. So you're going to have 5 squared plus 12 squared equals x squared. Let's draw a little dividing line here. And that's going to give you 169 equals x squared. Then just square root both sides. And you're going to get 13 is equal to x. Okay? So this side here is 13. That means this side is 13 as well. So 13. And now we've got 18 times 13. So we're going to have the left side. Left side is 18 times 13. So that's equal to, when you put into your calculator, you're going to get 234 meters squared. Now you're in a position to find the total surface area. So you just have to add up all of those numbers together. So if you're going to add 90 plus 60 plus 216 plus 234, you're going to get 600 square meters. Okay, so that's done. Now, last of all, we're going to look at the trapezoidal prism here. So we'll start off with the easy parts first. So we'll do the bottom. Bottom is just 24 times 18. Now, 24 times 18 is equal to 432 centimeters squared. Now the top is not the same as the bottom, that's different. The top is, that's 10 there. Whoops. You get the idea there. And this side here is what we need, that's 18. Okay, so the top will be 10 by 18, which is 180. So 180 centimeters squared, and then we'll look at the right side. The right side is easiest to work out. That's 18 times 13. So 18 times 13 is equal to 234. That's 234 centimeters squared. And then we can work out the left side. Before the left side, it probably helps to think of a dotted line which goes down to the back there to meet the corner of your trapezium. Okay, so you can see that the left side is going to be also 18 along there by 15. So 18 by 15. Now the side faces are all rectangles, so that's why we can use base times height for this trapezoidal prism. You're going to get 270 square centimeters. Now that leaves us with the front and the back. Now the front and the back are trapeziums. The height of this trapezium is 12. So we're going to start off with 12 on 2. Now the two parallel sides, one is 24. And this side here, this is the other parallel side we need to know. That is going to be 10, isn't it? So 24 plus 10. Now put that into your calculator. Okay, actually no. Before you do that, we know that the back is the same. So we're just going to double that to get the front and the back together. So it's going to be 12 times 34, which is 408, and that's square centimeters. And then you're going to add the totals together. So you're going to go 432 plus 180 plus 234 plus 270 plus 408. You should get 1524 there. So the surface area, the total surface area, is 1524 centimeters squared. And that's it. Now, actually, before we do that, if you're wondering where I got the formula for the last bit, so if you're a little bit stuck on this bit here, okay, remember the formula for trapezium we did at the beginning. For trapezium, it's h onto multiplied by a plus b, where a and b are two parallel sides.